بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will talk about conditional probability. Let's begin. A and B are two events of the same random experiment such that event B occurred before event A. So we have two events such that one of them happened before the other one. And in this case, we suppose that B occurred before A. The probability of A given that event B is realized is denoted by P of A slash B or P of A given B. Let's see this example. We have this table. It talks about boys and girls in a school. We have a humanities, LS and ES. One student is selected randomly from the school. Consider the events. H means humanities, L means LS, E means ES, and B means it's a boy. We need to calculate these probabilities. Now let's see how do we calculate conditional probabilities. First, in order to find P of H given B, in this case, we're going to see that the universe will be changed. Now, for the time being, the universe contains 100 students and the universe is going to be the students in grade 12. Whereas for conditional probability, we will see that the universe will be changed based on the event that occurred before, i.e. in this case, it's going to be based on B. Let's see what do we mean by this. If we want to calculate the probability of a humanities, given that it's a boy, so we come to the boy section only. This is what we do. These are the boy sections, and from the boy section we have to see the probability of selecting a humanity boy. So in this case it will be 15 over 47. So we have to see the new universe, which is based on the event that occurred before, and then after we find the new universe we calculate a normal probability. Now let's see the second example. Similarly, here we are still in the boys section and we need to calculate the probability of LS. It will be in fact 12 over 47. Now in this case we need the probability of a boy given that he is in the ES section, so the universe in this case would be the ES. So we hide everything but the ES section. We come to the ES section, and from this section we calculate the probability of selecting a boy. The probability in this case to select a boy would be 20 over 45. Now what is the probability of B bar given E? We are still in the ES section, but we need the probability of B bar, and B bar means the selected student is not a boy. In this case it would be a girl, and the probability of selecting a girl would be 25 over 45. Now the probability of E given B bar, in this case we go back to the whole grade 12 classes, and then we need the B bar. B bar means the girls, so we just come to the girls section, and from this section we calculate the probability of selecting an ES student. Now the probability of selecting an ES student in this case would be 25 over 53. And finally, the probability of B given B. In this case, we have to come to the boys section, which is the first row in this table, and we need to calculate the probability of selecting a boy. It will be the probability of a certain event, which is 1. Now let's see this example. We are still talking about the same table. Now, we can talk about the conditional probability verbally using words, using some terminologies, such that, for example, knowing that, we're going to see them all. Now, if we want to translate this statement into probability language, let's see how. Calculate the probability of selecting a boy knowing that he is in the LS section. This means that the LS section happened before selecting the boy, so we have a conditional probability, and this would be translated by the probability of B given L. which is in this case we have to hide everything but ls section. This is the ls section, and we need to select a boy from this section, and the probability in that case would be 12 over 30. So the terminology here, the keyword is going to be knowing that. And notice that the event that is going to be put in the numerator is going to be the event that follows calculate the probability directly. Now calculate the probability of selecting an H student given that it's a girl. This is similar to part 1. Now this would be the probability of H slash G. Remember, given that is the same as knowing that, and it is translated into this slash, and this is a conditional probability. So we come to the girls section, which is the second row here, and from the girls section we need to select a humanity girl, so it will be 10 over 53. Now this is a third type. The selected student is in the ES section. Point. Calculate the probability of being a boy. Here also we have two events such that one of them occurred before the other. The event that comes before is that it is in the ES section. This student is in the ES section, and then I need to calculate the probability of being a boy. First, let's translate it into the probability language. So it will be P of B given E. Remember, the light blue here directly after calculate the probability is going to be put in the numerator. So this is P of B given E. So we come to the ES section, and from this section we choose or we select the boys. The probability of selecting a boy, it will be 20 over 45. Now, this is also one of the ways to express conditional probability by English-wise. We know that we can either write the statement in the form of part 1, or we can use part 4. We just begin with knowing that or given that. So knowing that the selected student is a girl, comma, calculate the probability of being in the ES section. This also means conditional probability because we do have knowing that, and this is equal to P of E slash G. So we come to the girls section, and from this section we choose an ES student, so it will be 25 over 53. Now calculate the probability of selecting an LS girl. Pay attention, this is not a conditional probability. For conditional probability, as I said before, we have some terminologies such as knowing that, given that, statement with a point, and then calculate the probability and so on. So we must have two events, and it should be clear that one of the events occurred before the other. In this case, if we need to calculate the probability of selecting an LS girl, this would be translated as P of L intersection G. This would be the intersection between girls and LS, which is 18 in this case, over 100. Now calculate the probability of selecting a boy or an ES student. We saw this before. And means intersection as in part 5, and or means union. Now what is the probability of B union E? We select all the boys, which are 15, 12, 20, and then we select all the ES students, which are 20 and 25, but pay attention, try to show the common students only once. So this would be 15, 12, 20 from B, and the 25 is added from E without adding 20 another time, so it would be 7200. Now let's see this application. In this table we have the number of flowers in Ahmad's garden. In fact, we have red, white, and yellow flowers, and we have small and big. So the flowers are distributed depending on the color and the size. Ahmad wants to select randomly one flower from the garden. Calculate the probability of selecting a big flower knowing that it's white. Try to search for the terminologies and pay attention while translating the statement from verbal into probability. Well, this would be the probability of B given W, because you see, calculate the probability of selecting a big flower. The statement which is directly after calculate the probability, we put it up. And in this case, we come to the white section. This is the white section, and we choose the probability of a big flower, so it will be 19 over 30. Now calculate the probability of selecting a white flower given that it's big. Try also to do it alone. So it will be the probability of W given B. And in this case, we come to the big section, which is here. And from this section, we choose the white. So it will be 19 over 80. Now the selected flower is yellow. Calculate the probability of being big. In this case, try also to translate it. So it is the probability of B given a Y. We come to the yellow section and we find the probability of selecting a big flower. So it will be 35 over 50. Given that the selected flower is not yellow, what is the probability of being small? Pay attention to given that. This is also conditional. So given that the selected flower is not yellow, this is yellow bar, we need the probability of being small. So we have to come to the yellow bar sections, which are the red or white. From here, from this section, we need to choose a small flower, so it will be 25 over 70. Now calculate the probability of selecting a non-red flower. Pay attention. Now this is not conditional. This is in fact talking about the complement of red, which is non-red. To be non-red, so we must have 80 flowers out of 120. And see here that the total is 120. Now calculate the probability of selecting a small non-red flower. This is in fact intersection. We need it to be small and non-red. So a small R here and non-red are white or yellow, so we're going to have 26 over 120. And finally, calculate the probability of selecting a big flower or a white flower, and or means union. Try to do it alone. So this would be big. We have 26, 19, 35. White, we have 19 and 11. But pay attention, the common elements appear only once. So this would be the answer. I'd like you here to notice, please, that the probability of B given W, which is 1930, is not the same as the probability of W given B, which is 1980. Now let's see some properties about the conditional probability. Let's begin with this activity. We go back to this table. One student is selected randomly. Consider the events. We have the same events. Now calculate P of L. Let's see, the selected student is in the LS section. So to be in the LS, its probability is 30 over 100. Now P of L intersection B, we need the student to be LS and boy. So LS and boy, we're going to have 12 over 100. And P of B, which is the selected student, is a boy. To be a boy, the probability is 47 over 100. Now let's continue. Calculate the probability of L given B and B given L. Well, for L given B, we have to respect B first. B means boys, so we come to the boys section, and from this section we find the probability of selecting an LS boy. So it will be 12 over 47. And the probability of B given L, now here we have to come to the LS section, and we find the probability of selecting a boy. It will be 12 over 30. Notice here that in the first part we don't have any conditional probability, so the total is always 100, whereas in the second part we do have two conditional probabilities, so the total changes. Sometimes it's 47 and sometimes it's 30. Let's continue. Now, what relation exists among P of L given B, P of B, and P of L intersection B? Try to find the relation by looking at the numbers. Well, this is L given B, which is 1247, and we have this is 47, and this is a 12. So L given B is 12 over 47, B is 47 over 100, and L intersection B is 12 over 100. So I think it's very easy that P of L given B is P of L intersection B over P of B after we eliminate the hundreds. Okay, now what relation exists among P of B given L, P of L, and P of B intersection L? We have P of B given L is 12 over 30, P of L is 30 over 100, and P of B intersection L is 12 over 100. So we have a similar relation. P of B given L is P of B intersection L over P of L. Remember here, dear students, that P of A intersection B is the same as P of B intersection A. Now let's see the results. A and B are two events. P of A given B is P of A intersection B over P of B. From here we can tell that P of A intersection B is P of A given B times P of B. And this is also similar. P of B given A is B intersection A over P of A. And if we cross multiply, we get B intersection A is B given A times A. And if we just compare these two results, they are the same because A intersection B is the same as B intersection A. So we can say that the probability of A given B times B is the probability of B given A times A. Let's see some examples about these properties. A and B are two events such that P of A is 0.4, P of B is 0.5, and P of A intersection B is 0.1. The question is to calculate P of A given B and P of B given A. We have to see the relation that is going to be used. I think it's very easy. It's very clear that we're going to use the first relation. So for P of A given B, it's P of A intersection B over P of B. I know A intersection B and I know B, so I know A intersection B and I know B, so it will be 0.2. And for B given A, it's also a formula. It will be B intersection A over A, and probability of B intersection A is equal to the probability of A intersection B, so this would be 0.1 over 0.4, which is 0.25. Now let's see this application. E and F are two events such that P of E bar is 0.4. This is P of F and this is P of E given F, and the question is to calculate P of F given E. Try to do it alone, try to manage between these formulas and previous ones. Well, let's begin. If we want to find P of E intersection F, it will be P of E given F times P of F. I know E given F and I know F, so this would be 0.1. Now, if I want to use this, what is P of F given E? It's F intersection E over E. I know F intersection E, which is 0.1. And I know that P of E is 1 minus P of E bar, which is 0.6. So this would be 1 over 6.